Welcome to The Explainer. Today, we're talking about a paper with a title that sounds more like a philosophy than a technical breakthrough. Attention is all you need. But believe it or not, this paper is one of the most important ever written in AI. It pretty much sparked the revolution we're seeing today. So, you ever wonder how something like ChatGPT actually gets what you're saying? Like, how does it understand the jokes, the context, the meaning behind your words? Well, to get to the bottom of that, we have to rewind the clock to 2017. To a single moment that honestly changed everything.
All right, so here's how we're going to break this down. First, we'll look at the big problem AI researchers were stuck on. Then we'll get into the wild idea that completely shattered that problem. And finally, we'll see how that one idea led to the AI world we live in today. Let's do it.
Okay, so let's set the scene. Picture the world of AI back before 2017. When it came to understanding language, pretty much everyone was using the same kind of playbook. And that playbook? Well, it had a huge, frustrating problem baked right into it. The top dogs back then were these models called recurrent neural networks, or RNNs for short. You might have heard of things like LSTMs. They're part of that family. And look, they were smart for their time, but they had this one massive weakness in the way they read.
This really gets to the heart of the issue. See, those old RNN models read a sentence pretty much like you and I do, one word at a time, in order. But here's the thing. For a computer, that's incredibly inefficient. It's slow. And worse, by the time it gets to the end of a long sentence, it can totally forget what the beginning was about. That's a huge problem for understanding context.
So you've got this major roadblock, this sequential bottleneck. And it's exactly this problem that led a team at Google to ask a question that was so simple, so radical, it was about to turn the entire field of AI on its head. And what they proposed was just, wow. They said, let's just throw out that whole one word at a time thing. Get rid of it. Instead, they came up with a totally new design, a new architecture they called the transformer. And its entire foundation was built on one single, elegant idea: attention.
And this is the magic trick right here, self-attention. Imagine instead of reading a sentence word by word, you could just absorb the whole thing in a single glance. That's what self-attention does. It lets the model look at all the words simultaneously and figure out how they all relate to each other. It's like instantly seeing the entire web of connections that gives a sentence its meaning. Game changer.
Okay, so we have this amazing idea of attention. Now let's peek under the hood and see how it all fits together inside the transformer model, which, by the way, is pretty much the blueprint for all modern AI.
All right, here it is, the famous diagram from the paper. I know, it looks super intimidating, right? But don't worry, it's actually just made of a few key pieces that repeat. On the left side, you've got the encoder. Think of that as the part that reads and understands. On the right, you have the decoder, which is the part that writes the answer. And the engine driving both sides? You guessed it, that attention mechanism we just talked about.
And this is where it gets even cooler. The researchers thought, okay, paying attention is great, but what if we could pay attention to different things at the same time? So they invented something called multi-head attention. It's exactly what it sounds like. It lets the model look at a sentence from multiple angles all at once.
The best way to think about it is like having a team of specialists all looking at the same sentence. You know, one is a grammar expert, another is focused on the who did what to whom, maybe a third is just checking the overall vibe or sentiment. Each head has a different job. And by putting all their insights together, the model gets this incredibly rich, deep understanding of the text. It's genius, really.
Okay, but hang on a second. If you're looking at all the words at once, doesn't that scramble the order? I mean, dog bites man is very different from man bites dog, right? Great question. The authors had a super clever fix for this called positional encodings. They basically stamp each word with a little bit of information that says, hey, I'm word number 1, I'm word number 2, and so on. That way, the model gets the best of both worlds. It sees everything at once, but still knows the original order.
So, this was a beautiful idea on paper. But did it actually work? Oh boy, did it ever. When they ran the tests, the results weren't just good. They were so good, they basically sent a shockwave through the entire AI community.
Take a look at this number, 28.4. Now that might not mean much to you, but in the world of machine translation, it was a bombshell. This was the new record-breaking score on a key test for translating English to German. And it wasn't just a little better. A jump this big was a huge leap in quality.
And I mean, just look at the comparison here.
The transformer didn't just nudge past the old champions, it left them in the dust. We're talking more than 2 full points higher, which, trust me, in this field, that is a massive, massive deal. It's like a runner not just breaking the world record, but smashing it by several seconds.
And get this is the best part. It didn't just break records, it did it while being way more efficient. Because it could process everything in parallel, it took way less computer power to train. So it was better, it was faster, and it was cheaper to run. That's the trifecta right there.
But the story doesn't end with better translations. Not even close. The real impact of this paper was that it completely changed the rulebook for how to build AI.
This new design, the transformer, was the key that unlocked our current era of AI. It's what allows us to train these gigantic models on massive amounts of data. You know, models like GPT? Well, what do you think the T in GPT stands for? Generative Pre-trained Transformer. Yep, the DNA of today's most powerful AI comes directly from this 2017 paper.
You know, at the end of the paper, the authors wrote this line about being excited about the future. Talk about an understatement. They must have known they had lightning in a bottle. They didn't just build a better mousetrap. They gave the entire world of AI a completely new toolbox to play with. So, when you boil it all down, this one simple, powerful idea, attention, is the bedrock of the AI revolution we're living through right now. It was the key that unlocked a door no one even knew was there. Which kind of makes you wonder, doesn't it? What's the next simple, radical idea that's going to change everything all over again?